Hello, this is Rishikesh Upadhyay, and my cohort name is Cohort Crawl. Today, I'm here to present Capstone project design and analysis of algorithms. The first question I want to talk about is the power of two puzzle. So there was a bug in this code which I fixed it, and I want to elaborate this code as there is a function is power of 2 that takes a number n as input and returns a boolean value. N greater than 0 checks if the input number is greater than 0. This condition ensures that only positive numbers are considered, whereas n and n minus 1 triple equal to 0. This part checks whether the input number is a power of 2. In binary representation, a power of 2 has only one bit. When you subtract 1 from a power of 2, you get a binary number with the 1 bit up to the original number. The bitwise AND operation is used to check if there are no common 1 bits between n and n minus 1. If the result is 0, it means that the only one bit is n, indicating that it's a power of 2. Now I want to talk about coding bug fixing. Question number 4. Mac is organizing a talent show in her community and needs to arrange the participants using the sort people function. The function takes two arguments as an array of names and an array of heights. So we have to sort it in a descending order. So I used a function called sort people with two arrays, names and heights as input. Let map new map initializes a new map, associate each height with its corresponding name, and for loop iterates through the height array. For each height it uses map set to associate the height with the corresponding name in the map. Height.sort uses the sort method to sort heights array in descending order. The sorting is based on the comparison function. Then let res is an empty array initializes as an empty array to store the stored names. The second for loop iterates through the sorted height array, and for each height it uses map.getHeight to retrieve the corresponding name from the map and pushes it into the res array. The result is stored in the res, returns the final array of the names sorted descending order based on their corresponding height. Now I want to talk about improvised perspective to the coding problem and question number 7, palindromia. So we have to determine a palindrome number of a given number. So I defined a function called isPalindrome that checks whether a given number n is a palindrome number that reads the same from backward as forward. So checking for negative numbers, I used if n is less than 0, then I should just revert back and initializing variable let original num equal to n and reverse num equal to 0. Then I reverse the number while loop with using my loop and continues as long as n is greater than 0. Inside the loop, the last digit n modulus 10 calculates the last digit of the n using the modulo operator, and reverse num into 10 plus last digit builds the reversed number by multiplying the current reversed number by 10 and adding the last digit. The n equal to mat.floor n by 10 removes last digit from the n by performing the integer division. The loop effectively reverses the digit of the original number. And lastly, I just checked from the original number if I compare it to the reverse number, and if it's true, then the number is palindrome. Now I'm gonna talk about the question number 10, which is first and last position of an element in a sorted array. The search range function takes an array of integer num sorted in non-descending order, a target value, target, and returns a pair of integers representing the starting and ending positions of the target value in the array. If the target value is found If the target value is not found in the array, the function returns -1 -1, and the area is determined to write an algorithm that utilizes the search function. Okay, so for this question, I wrote a helper function. Let find position equal to function target is first, defines a helper function that names find position that takes the target value and a boolean is first as a parameter. This function is responsible for finding the first or last occurrence of the target value. The binary search for the first and last occurrence, I used left equal to 0 and right equal to nums.length -1, which initializes pointers, and when using while loop, it performs a binary search, calculate the middle index, and checks if the middle element is equal to the target. If true, updates the result variable with the current index, adjust the search range accordingly based on whether the goal is to find the first or the last occurrence. In the middle element is less than the target, adjust the search or range to the right. If the middle element is greater than the target, then adjust the search range to the left. The binary search continues until the search range is exhausted. After getting the results are an array containing the indices of the first and last occurrence of the target value. The function uses a binary search approach to find the first and last occurrence of the target value in the stored array and returns an array with the indices. If the target value is not present, it returns -1 -1. Lastly, I want to talk about logic building coding question, peak element. So, a peak element is an element that's strictly greater than its neighbors. Given a zero indexed integer array nums, along with the find peak element function, your goal is to find a peak element and return its index. If the array contains multiple peaks, you can return the index to any of the peaks. So, I made a logic for this question, and here it is. So I created a first peak element function is designed to find the peak element. Initializes pointers from left equal to 0 and let right equal to nums equal to length -1. Binary search, a while loop, continues until the search range is reduced to a single element, and calculates the middle index. Checks if the element of the middle index is greater than the element to the right. If true, it means the peak element must be on the left side or could be the current middle element. Therefore, it updates the right to mid. If false, it means the peak element must be on the right side. Therefore, it updates left to the mid +1. This process eliminates half of the search space in each iteration, narrowing down the range where the peak element can be found. After the loop, when left and right are equal, the function returns the left. This is because at this point, the left and right points to the same element, and that element is a potential peak element. In summary, the function effect the function The function efficiently searches for a peak element in a given array using a binary search approach. It continuously narrows down the search space until it identifies a potential peak element and returns its index. Thank you so much. This was my Capstone project, Design and Analysis of Algorithm. This is Rishikesh Upadhyay from Cohort Crawl.